Let's review your MT3 LT4 seminar on writing proofs. First thing I want you to do is I want you to do questions 1 through 5, and we'll review them in class, or at least do them as a warm-up. And I want you, in this lesson, we have 4 things I want you to learn. I want you to analyze figures and identify and use postulates about points, lines, and planes. A postulate is something we accept without proof. We're going to analyze and construct valuable arguments in a 2-column proof format. We're going to do a flow proof, and we're going to do a paragraph proof. And since today is the first part of it, we're not going to do an entire proof by itself. You're just going to fill in parts, and we're going to slowly work our way into more and more parts as we do proofs. This could be one of the most complex things we do in class. Now, a proof is something you're showing why something is true. There's a famous proof called Fermat's last theorem. And what it is, you've heard of the Pythagorean theorem, a squared plus b squared equals c squared. And what Fermat was saying, hey, if I have something bigger than 2, then that's not going to work. Okay? And he proved it for 4. Like, there's no number. You can take a to the 4th plus b to the 4th, and they'll equal c to the 4th. But he got into, this is like in 1657, and he had that masculine problem where they got into an argument. He was having a duel the next day, so he frantically was going through his notes the night before the duel. And yes, he died in the duel the next day. And he wrote on the side, hey, I can prove this. I can show this is true. The problem is, nobody else could. And people worked on this for years and years and years. And as you can see, in the year 1908, they offered a cash prize, like $1 million, to prove it. And a bunch of people tried it, and finally in 1995, this mathematician named Andrew Wiles, he published 2 papers that did the proof. Although you think you have homework, imagine having homework for hundreds of years, because that's what mathematicians do. They look at each other's works and critique it. And you're a mathematician, so you're going to have to do that today. Hopefully you don't have to spend hundreds of years on today's assignment, because I don't know how I'm going to grade that. Here are our basic postulates. And they're numbered, but I don't care about those numbers. On your assignment, they're going to ask you for the numbers. So if you get the assignment, if you get a question wrong because of the numbers, I really don't care. I'm going to look at, can you get the meat of the situation? When we take our test, I won't ask you for numbers. I will ask you to write down these postulates. So let's go over these first 7 postulates. It says through any 2 points, there's exactly 1 line. So it's saying, hey, if I've got 2 points, I've got a line that goes through them. And it says through any 3 points not in a row, we've got a plane. If we have a line, we know we have at least 2 points. And we have a plane, we know we have at least 3 points not on the same line. If 2 points line a plane, then the entire line containing those points lies in the plane. So if I've got these 2 points in the plane, the line that contains them, because we know 2 points make a line, I know that line lies in the plane. If 2 lines intersect, they intersect at a point. And finally, if 2 planes intersect, they intersect in a line. And I'm not very good at drawing that, so I'm not going to even try. But we can see that on example 1. Notice I've got the plane of the front of the building here. I've got the plane of the side of the building. Where those 2 planes intersect, I've got a line. Now if I take a look at example 1, lines N and P intersect at point D. That is what we just said, postulate 3.6. And like I said, I don't care about 3.6, but we know if two lines intersect, they intersect in a point. Points A, B, maybe and D. Here's A, here's B, and here's D. They determine a line. Well, that is our postulate 3.2 then, isn't it? Through 3 points, there is a line. Or plane, I'm sorry, I said that wrong. So if you haven't figured out on your assignment, I want you to refer to your notes here and eventually get this memorized, because we want to get this memorized eventually. And then part C says the plane containing A, D, and E intersects the plane F, G, and E in line K. That's our last postulate, isn't it? That's 3.7. And 3.7 says if two planes intersect, they intersect in a line.